Hey, it's Matthew Todd and welcome back. Welcome to Module 3. I hope that you've had time to complete the actions from Module 2 and make some progress on the coding exercises. If not, then don't worry. You do have lifetime access to the course, so I really would encourage you to come back to this module once you've had a chance to complete those actions, and I've had a chance to give you some feedback on those as well. As mentioned before, I really do want you to get the most out of this course, and I know that if you do follow the actions, allow me to review your work, provide feedback to you, then I know that you can make massive amounts of progress in a very short amount of time. You can become one of the best developers in your team or organisation without needing years of experience, because after all, experience is only useful if it's the right experience, and that's what I'm trying to provide you with here. So assuming you've had a chance to complete the exercise, or at least get to a point where you've got a few tests, behaviours implemented, and you've had a chance to get feedback from me, then what we're going to do in this module is build on top of that and look at refactoring. We're going to see how using testing for purpose not only provides a benefit in terms of speed of development, consistency, quality, when writing the test and code initially, those benefits also carry over to refactoring. We'll see how TFP makes refactoring safer, something that can be done reliably with less risk, and compare this to how I commonly see tests actually making refactoring harder, more complex than it needs to be. So far, the demonstrations and discussions we've had are on the assumption that when we talk about a test, or test-driven development, we're really talking about unit tests. In the next module, I'll go beyond that and talk about other types of tests and how they fit in with TDD. But for now, I want to focus on unit testing and drill a little bit deeper on this. But do bear in mind, these principles will also apply to other levels and types of testing and development. So in this lesson, I want to talk about exactly what we mean by a unit, because as it turns out, people have different opinions on this, and that's not necessarily a bad thing. So what do we mean by a unit? Is it a class? Or perhaps if we were taking a functional rather than object-oriented approach, is it a namespace or a module? And if it is a class, is it just a class? And is it always just a class? My answer to this is it depends. Now let's look at some sample code now and I'll show you exactly what I mean. I'll show Java code for this, but again the principles are the same no matter what language we are using. So with this simple class, I think we can clearly see it has no dependencies on any other classes. It does use the big decimal class, but that can be considered more of a data type than a class that encapsulates a set of responsibilities or behaviours. So for this class, we can say it is self-contained, and something that in the context of unit testing is something we would happily say is a testable unit in its own right, so it wouldn't require any kind of mocking or stubs or any other kind of testables to be used. So on to something slightly more complex. So here we have another class, and this time we can see this class does have more dependencies. The dependencies we have for this class are ones which are used for ancillary actions. They're not a core part of this class. We have some logging, we have some code relating to metrics, but they're not a core part of the business logic associated with this class. So from a test perspective, these are dependencies we would seek to exclude from our testing. We would provide test doubles to act in place of these dependencies. So from thinking about what we mean by unit in this case, is purely the signing key generator class that we would consider to be a testable unit in isolation, not using real implementations for any of its dependencies. So on to another example. In this example we can see we have another class, eBay order downloader, that has some dependencies. This time the dependencies are different to the previous one. They clearly do have a role in the core business logic of this class. We have an order store of some kind, which is a dependency passed in on class construction. We also use some third-party classes, namely those from the eBay SDK, the API context class, which is also provided as a constructor parameter. So the question when it comes to unit testing this code is what do we mean by unit in this case? For a lot of developers, their perspective on what a unit will be only governed by structure. They'll focus on testing structural units. What I mean by this is that purely the structure of the code will dictate the breakdown of testable units. Basically, there'll be a test for every class. So in this case, this class would be unit tested, and all of these dependencies, all of the classes you can see here, would be replaced by test doubles, mocks, stubs, etc. There are other dependencies in this class though that we haven't mentioned, such as the list, ArrayList, string builder classes, as well as a monetary value class that's part of our application package. If we're choosing to test the eBay order downloader in isolation, then shouldn't we be providing test doubles for these dependencies too? I think you could choose to argue a case for doing this, but in this case, as the dependencies are either part of the standard system library or simple classes to serve as value containers, such as a monetary value class, they can be assumed to be working, but more importantly, they are not performing operations that would interact with any external system. These are not classes designed to encapsulate any behaviour. They're pretty much acting as different kinds of data structures, so they don't contain any business logic that we should be testing independently. So in this case, we can choose not to mock or stub these. So this is considering our units based purely on their structure, taking a view to test each of our structural units independently. We could, if we wish though, take a different view, and rather than structural units, consider logical units. As we saw from the previous example, where there were some system classes we would choose not to replace with test doubles, not all classes are created equal. There are many reasons a developer might choose a particular logical structure, particular package structure, module structure, file system layout for their source code. Because of this, it may be that for a particular developer, or for a particular part of the code base, they choose to see a small set of tightly coupled classes as being part of the same logical unit. So when it comes to unit testing the main class, all of these other classes could be argued to be a part of the same logical unit, so therefore should be tested as part of this class, not mocked or replaced by some kind of test double. In this case, these other classes would not have their own tests, they'd only be tested by the unit test for the main class. They're considered to be a key component of the main class. For instance, we didn't discuss what the order store class in our eBay order downloader did. We can probably guess it would serve as a data store for orders we want to retrieve, but if we wanted to, we could choose not to provide a test double for this dependency and use the real implementation instead. If, and only if, we took a viewpoint where we consider the order store to be inseparable from the eBay order downloader class. Now you could argue against designing an application this way, but I have seen many applications, more so in the Java or .NET land, that are over-designed, with too many artificial layers and abstractions that don't actually serve a useful purpose. But in order to bring these kind of systems under test, to have them tested with the right kind of tests, using our testing for purpose strategy, I think it's important to realise that it can be a valid thing to do, to view your code base as a number of logical units that may go beyond a single class, and therefore this can affect how you approach the unit testing. I think it is less common, and might only be something you have to do when you're trying to refactor and improve an already complex system. But it's something I want to highlight in order to make you think about A, the abstractions that you have in your code base, and B, whether the structure of your code base actually bears a close relationship to the logic. So I want to leave it there for this lesson and leave you to think about your code bases. Do the layers and abstractions in your code bases make sense? And if you were to think about logical versus structural units, would there be a difference in your code base between these two viewpoints? Do the layers and abstractions that lead you to see a collection of classes as a single logical unit, are they genuinely valuable and useful abstractions? Perhaps this highlights refactoring work that you need to do, or might affect how you could test these logical units compared to what you're doing at the moment. So I'll leave it there for this lesson, and look forward to seeing you in the next lesson, where we talk about how refactoring can change the units that you have in your application.